Our last topic this week is an interesting one. Grouped queries. So every SQL query is one of two types. Either it's an ungrouped query or a grouped query. And the vast majority of the queries that we've seen so far have been ungrouped queries, like this one here. Here's an example of a grouped query. Let's have a look at this. So what's happening here? Well, what's happening is that we are grouping rows in the customer table. We're forming row groups based on the value in the state column. What does that look like? Study Guide tries to show us what's happening there. So when we start with a customer table and we form row groups based on the value in the state column, this is what we end up with. 3 groups. One for the Queensland rows, one for the New South Wales rows, and one for the Victorian rows. Now, for a grouped query, the select clause produces a single output row for each group. And that's the result that we get. And this query tells us the number of customers from each state that appears in the customer table. So that's a grouped query. Now, we're on this query. In fact, I can just pop back there and just make a change to this query. If I add an additional column name from the customer table into this query, we get an error. And the error says customer.name, that's the column called name that came from the customer table, is invalid in the select list. So here's our list of items in the select clause, and it's saying that name is not valid in the list of items in the select clause. Why? It says because it is not contained in either an aggregate function or the group by clause. So if we use name in an aggregate function, the query works quite happily. Or if we place name into the group by clause, the query is happy again. So there we are. But in the absence of name appearing as an argument to an aggregate function or appearing in the group by clause, we will get this error. So that's the rule for queries that have a group by clause. Any columns that appear in the select list must either be an argument to an aggregate function or must appear in the group by clause. And of course it does make sense. If you look at our query here, we're asking the database engine to select a state and a name value out of each group, grouped formed by the value in the state column. So here are those groups, and here are the 4 rows with a state value of QLD. But of course notice that these 4 Queensland customers have different names. So when we ask the database engine to group customer rows by state, and then for each group select the state value from the group and a name from the group, you can see that the database engine is going to have a difficulty satisfying that request. It's happy to pull out a state value from the group because it knows that all rows have the same state value. It knows that because we have explicitly grouped the rows by the value in the state column. So all rows in the group will have the same state value. But the rows in the group can have a different name value, as you see here. So how can the database engine select a single name value from the group? That makes sense. Now, just as a point of interest, we might consider, well, what happens if we do put name into the group by clause, and interestingly we end up with 5 rows produced as output. Why is that the case? Well, I guess it must mean that we have 5 groups produced when we group rows in the customer table by the combination of state and name values. Does that make sense? Well, if we come back to the study guide, you can see that that does make sense, because obviously the one row describing a New South Wales customer will go into a group. The one row describing a Victorian customer will go into a group. But now the Queensland customers, of which there are 4, will go into 3 groups. We've got 2 Queensland customers with the name of Best Kitchens. We have one with the name Sheila Smith and one with the name Samir Singh. So now the Queensland rows will be broken up into 3 groups, giving us a total of 5 groups, which is what we see in the result there. Now, a query that includes a group by clause is called an explicitly grouped query. So, the rule for an explicitly grouped query is as follows. Any column that appears in the select clause must either be contained as an argument to an aggregate function or appear in the group by clause. Now, as well as explicitly grouped queries, queries with a group by clause, in SQL we also bump into the idea of an implicitly grouped query. Let's have a look at this query. Now, this query, notice, produces one output row. Now, this is what we call an implicitly grouped query. What's happening here is that all rows in the customer table are being treated as a single group. Now, how comes? Why is this query being treated as a grouped query? And the answer is because we've used an aggregate function. So the query processor has inferred from the fact that we're interested in a count of the CID values that it wants to apply a count to all of the CID values in the customer table. It wants to treat all rows in the customer table as a single group of rows and then to count those CID values, producing one output row. Now, this query is identical to this one here, and it produces the exact same result. So here what we've done, we've converted this query from an implicitly grouped query into an explicitly grouped query. And what we're grouping by here, well, we're grouping by an empty list of column names. So you might be an interesting mental exercise for you to just convince yourself why, when we group by an empty list of column names, all rows go into the one group. Just an interesting little mental exercise. So there we go. The idea of an implicitly grouped query. The implicit grouping occurs as a result of the use of an aggregate function. So watch out for that. Now, the final clause that we come across in an SQL query is the having clause. So let's have a look at this query here. So we're saying I'm interested in selecting the state from the customer table, having grouped rows based on the value in the state column, and I'm interested in those groups having a count of customers, customer IDs, greater than 1. What do you think that will produce as a result? It will produce the value Queensland. So there we go. The having clause is a group filter. As you know, a where clause is a row filter. If we have a where clause in our query, it acts as a filter on the rows that emerge from the from clause. You can chop some of those rows and throw them away. The group by having clause has the same effect on groups. So the having clause is to groups what the where clause is to rows. So the having clause says, well, I'm only interested in those groups when the following is true. So the having clause is a group filter. And at that point, we are in a position to present our final procedural model of query processing. And remember, why are we presenting this model? We're presenting this model because when it comes to complex queries, it's easier to understand what those queries are doing if you adopt this procedural way of trying to make sense of them. So here it is. Here's our final procedural model. So let's have a look at it. We start out by the from clause. Start on the from clause. Evaluate the table in the from clause. Then we apply a filter. If the query has a where clause, we apply the where clause filter to filter those rows. Then, well, what happens next depends on whether or not we're using a grouped, whether or not the query is a grouped query or not. So if it is a grouped query, we come down here. Group the rows based on the group by clause. Or if it's an implicitly grouped query, then it'll be grouping by an empty list of column names. So we do our grouping, and then if we have a having clause, we filter the groups based on the having clause. And then with the filtered groups, for each group that emerges from the having clause, each group is passed across to the select clause one at a time to produce a single output row, which produces our result table plus will be the additional columns for sorting purposes. And then if we have an order by clause, we do our sorting, which produces the final output table. So that's what we do if it's a grouped query. And if not, what happens is, following the where clause, is that each row is passed across to the select clause, and for each row passed across, we produce a single output row to produce the result table, which can then be sorted by the order by clause. So that's the big point of difference between a grouped and ungrouped query. In an ungrouped query, the select clause produces an output row for each input row. With a grouped query, the select clause produces a single output row for each input group. So there we go. There's our procedural model of query processing. Hopefully that makes sense, and hopefully it will serve you well when we as we start to look at more complex queries. Hopefully that makes sense.